Dear students, welcome in the Mr. Seni's physics class. Today's topic of discussion is about waves. In this topic of waves, you will get chance to learn the following subtopics: concept of waves, propagation of waves, behavior of waves, sound waves, musical sounds, and electromagnetic waves. Concept of waves. What happens on the surface of the water when a stone is dropped into a pond of still water? Some disturbances in form of ripples will be created on the surface of water, which spread outwards in a circular pattern. When the stone hits the surface of water, the energy of the stone is transferred to the water molecules at the point of contact, causing the water molecules to vibrate up and down, up and down. The vibration disturbs the neighboring water molecules in the process, resulting into transfer of energy, which is observed at the movement of the disturbance outwards. Basically, the water molecules do not move outwards with the disturbance. Only the disturbance moves out. The movement of the disturbance is called a wave. Now, what is a wave? A wave is a periodically repeating disturbance that travels through a medium from one location to another without a net movement of the medium or particles of the medium. Wave terminologies and the parameters. Crest. Crest is the point of maximum positive displacement of the medium particles from the equilibrium position. Trough. Trough is the point of maximum negative displacement of the wave medium particles from the equilibrium position or still position. Amplitude. Amplitude, this is the maximum displacement of the medium particles from equilibrium position. The SI unit of amplitude is meter. Wavelengths. Wavelengths is the distance between two successive crests or two adjacent tracks. Or you can define wavelengths as the distance that the wave travels in one complete cycle. The wavelength is represented by the Greek letter lambda. And the SI unit for wavelengths is meter. Well, another term is period. T is the time taken for the wave to travel from a crest to the next crest or from a trough to the next trough. Or you can define period is the time taken to make one complete cycle. Period is equal to time of travel divided by the number of complete cycle. That is, capital letter T is equal to small letter t over n, where capital letter T stands for the period and small letter t stands for the time taken and n stands for the number of complete cycles. The SI unit of period is second. Another term is frequency. Frequency is the number of waves that pass a certain point per specified amount of time. Or you can define frequency is the number of wave cycles completed in 1 second. Frequency F is equal to number of cycles divided by time. That is small letter f, which is stands for frequency, is equal to small letter n over time, where small letter n stands for the number of complete cycles and t stands for time. From the definition of period, t is equal to nt. Thus, f is equal to n over nt, which is equal to 1 over t. Hence, frequency is equal to 1 over capital letter T, or you can say frequency is a reciprocal of period. And this is the relationship between period and the frequency of the wave. The SI of frequency is cycles per second, or hertz. That is to say, 1 hertz is equal to 1 cycle per second. Another terminology is wave velocity or wave speed. What is wave velocity or wave speed? Wave velocity is the velocity at which the wave moves through a medium. Or you can define that wave velocity is the distance traveled by a wave per unit time. The SI unit of wave velocity is meter per second. Another term is phase. Phase refers to the angle-like quantity that represents the fraction of a cycle covered in a certain time t. Or phase is normally denoted by phi. Relationship between wave parameters. Here we are going to see the relationship between wave velocity, wavelengths, and frequency. From the definition that wave velocity is equal to distance traveled over time taken. When a wave completes 1 cycle, the distance traveled L equals to the wavelength, and the time taken to complete 1 cycle is t. Then the wave speed or wave velocity is equal to wavelength over period. But frequency is the reciprocal of period. If you substitute in the equation, you get wave velocity is equal to wavelength times frequency. Example 1. Determine the amplitude, period, and frequency of the wave represented in the displacement time graph. Solution. Since the amplitude is the distance from the central line to the top of the crest or to the bottom of a trough, therefore amplitude is equal to 0.50 meter. The period. Period is the time taken to complete 1 cycle. So in a figure, the period is 0.2 seconds. The frequency of the wave. The frequency of the wave equals to how much? From the definition of frequency, or from the relationship between frequency and period, that frequency is the reciprocal of period. Then frequency will be equal to 1 over 0.2 seconds. Therefore, frequency is 5 hertz. Example number 2. Determining the wavelength and wave velocity of the wave from the displacement time graph corresponding to a wave in example 1. From the graph, the wavelength is the distance between two successive crests. Therefore, the wavelength is equal to 2 meters. The wave velocity is equal to how much? From the definition that wave velocity is equal to wavelength times frequency, therefore 5 hertz times 2 meters equals to 10 meters per second, which is the wave velocity. Example number 3. What is the wavelength of the wave whose speed is 4 meters per second and the frequency is 2 hertz? Solution. Given that speed equals to 4 meters per second, frequency equals to 2 hertz or 2 per second, wavelength equals to how much? From the definition of wave velocity equals to frequency times wavelength. Make wavelength the subject, you get wavelength equals to velocity over frequency, which is equal to 4 meters per second over 2 per second. Therefore, wavelength equals to 2 meters.